what I want to do now is look past measuring data into working with measured data. So how do we analyze measured data? Okay, so we're going to look now at a couple of capabilities that exist inside ENCODE's GlyphWorks software that can help us with the challenge of raw data, drowning in raw data, to providing answers or solutions. So then when your manager comes to you and says, okay, it's awesome you collect data, what I'd like to know now is, what can we learn from that? So we'll spend the rest of the day today talking about ways we can learn from these, what I would call squiggly lines, this kind of data we're collecting from this vehicle or from whatever your test article is. What we're going to look at now is the data that Scott has been collecting for us. This is GlyphWorks. How many people here have used ENCODE GlyphWorks software? All right, good. A number of you have. How many people have never seen this before? It's okay to raise your hand here. We're just going to laugh and point. All right, that's fine. Okay, so this is GlyphWorks. If it looks a little bit different than your GlyphWorks, no need to panic. It just happens to be that I've put the glyph palette with all these glyphs over here on the right side along with my available data window, just so that I have a little more screen space for you guys to look at. Okay, it's still the GlyphWorks that you may know. The data that Scott has been collecting from his vehicle is all of this. It's all multi-run SIE files. And we're going to take a little look here at what this data itself looks like. I'm going to open up an existing process, actually, to work with. Let's see what I'm working with here. Yeah, OK. So we'll open up an existing process. And that's over here, trip analysis. OK, so for those of you that have used GlyphWorks before, we have this concept of building a process out of these blocks or these glyphs, put them together. And some of the stuff I'm going to put together today, others I'm going to use existing processes. That's what I'm showing right here, so we can reuse what we build. I'm going to take one of these data files here, drop it in this way, and let's just take a quick look at what this data looks like. OK, so we have a number of channels of data here. We actually end up with, speaking of number of channels, how many channels you asked? It's about 100. Okay, so some of this is collected at high sample rate. These accelerations here are collected at, I believe, 500 hertz. We've got a lot of CAN bus information here, a lot of information from the transmission, from the engine, from the vehicle, right? This has been a big change in the last 10 years, is our ability to get data off of a vehicle or control area network instead of putting on transducers of our own. So that raises some challenge. To be honest with you, some of this CAN bus data is of questionable quality. It comes and goes. Scott put up a real-time display of the time series of CAN bus speed, what the vehicle's moving at, the speed it's moving at. Anyone remember this? It was a plot, and he said, oh, the scaling's way off. Like the highest speed it said was, I think it was 1,200 miles per hour. And that was Chris driving, yeah. It's someone else's vehicle, you know? Yeah, yeah. Just trying to keep up with traffic. Anyway, so some of this you'll find, we'll look at this CAN bus data. Some of it's got some suspect quality just because of the way the CAN bus allows messages to be sent in red and so on. A couple of accelerometers. These are we saw these in videos that Scott showed earlier, the actual accelerometers on the strut towers, for example. We also have GPS. If we look further down here, we have a number of GPS channels. Lat, long, speed, altitude, and so on. So part of what I'm going to look at today is these analyzing these squiggly lines, as I call them, with statistical tools and things. And I want to focus actually not just on some basic glyphs, but I want to extend into specifically 3 things that are new in GlyphWorks recently. And one is some enhancements to the GPS display glyph. Another is the way we interact with video. We've been interacting with video for a while. But SIE as a file format with video embedded in it opens up some possibilities, so I'll show you how that works. So that was GPS video, and then we're going to look at a new display called Xyz, which allows us to look at, kind of like looking at surfaces, looking at multivariate 3-dimensional plots. So let's take a look here. Go ahead and run this process. And I'll step through some of these glyphs one at a time here, and we can see what we have. All right, so let's start up here. This is GPS display. And GPS has been available for plotting inside GlyphWorks for a number of years now. What's unique, what we've just added recently, is so we've got this route that's been there for a while, and we can what we added that's new is now we can color the route, right? So in here I've told it latitude, longitude. That helps us plot the route, but I also have this option to color the route based on some channel. So this could be strain gauge data, it could be load, temperature, pressure, acceleration, and so on. I'm actually going to do something quite simple, and I'm going to color this based on speed from GPS. So then we see a plot that looks like this. So now we've got 10 colors automatically shaded from the lowest speed to the highest speed. I can set up the legend to work other ways if I want to go. Say, for example, if I have GPS speed that says I was going 1,200 miles per hour because, or CAN bus speed, it's erroneously given us this bad data back. We could clean it up with glyphs, or we could simply leave it off the legend. So we're going to do 10 intervals of color from 0 to 100 miles per hour, or maybe 0 to 80 miles per hour, so we don't show things we shouldn't have been doing, right? So this coloring GPS here, this is new for version 9. So how many people are using version 9 right now? Version 9, okay. All right, so if you have GPS, you have version 9, any channel data that you have can be used to color the route this way. And you may be wondering, this is a presentation by an ENCODE person. Why isn't this plot really super cool looking? Right? The background is very boring. Okay? So if I had it my way, I would put a really cool background in this. I'm actually going to show you this in just a minute with a glyph that's in development right now, with a version 9.1, and something you can't do right now at your desk, but I'll show you we're going to have a satellite view that's zoomable and stuff. I'll show you that in just a minute. In case you're wondering, this is kind of cool, but also not really terribly descriptive of where I drove. We'll get to the terribly descriptive of where I drove in just a minute. Currently, at version 9, the background is either this or a background that's rendered by Microsoft MapPoint. That's been around for a while. I'm not going to show MapPoint because there's something even cooler, and that's this next thing I'll show. Before I go there, though, I just want to point out that we have, with GPS, we have the ability to cursor through. So, for example, I can look at this channel here and cursor through. So I'm moving the cursor on the time series display, but since the data was recorded synchronously on the EDAC, this means now that I have time shared between the two. So I can see then, I'm coloring the route based on vehicle speed, but now I'm mousing through or cursoring through another parameter as well. In this case, one of the accelerometer channels. So again, I have this link in. It's one thing to look in a time series display and say, what the heck happened right there? This accelerometer, by the way, is behaving poorly right now. This is what we would call accelerometer gone wild. This is not behaving the way it ought to. But the nice thing about this is that if I cursor through this, I can see when did that happen. It was when I was driving up in the upper northwest of my map there. Okay, so this, I'm showing you some things that have been around for a while in GPS. The cursor tracking, the plotting. I'm showing you one thing that's new in version 9, and that's coloring this route. And what I want to do skip over here now and show what's cool and new. And that is in version 9.1, this is a beta build. So I'm going to follow in Scott's white knuckle footsteps here and use this piece of software that's not officially released right now and show you something that's cool and new here. What you need to know about 9.1 of ENCODE is it's coming out late summer. And it's going to have a number of enhancements. So for those of you guys trying to play along at home, major release, start of the calendar year, ENCODE 9, ENCODE 8, ENCODE 10. Minor release, probably on the average once or twice throughout the year. So 9.1, late summer, is our next minor release. The thing I want to point out here is, as I've alluded to now, is the GPS display. So same display as before, but oh, look at this. We're going to get something new here, right? Oh, yeah. Oh, look at that, okay? So why the heck does this say, here I am in Georgia and going out into the ocean? So this is where Scott gets nervous about loaning his keys, right? This is not a good thing. Well, the reason why is that this glyph plots out latitude and longitude by finding the first channel it can called latitude and finding the first channel it called longitude. Now, unfortunately, the CAN bus just broadcasts a very poor representation of latitude and longitude. It actually does it in a very strange way, in a way that's not physically where I'm in the world. It actually uses 3 channels of GPS, one for degrees, minutes, and seconds. 3 different channels. You've got to combine those together to get real GPS out of it. So I'm going to tell this glyph now, I actually want to use not the CAN GPS, but the GPS, the one from my external GPS device that I've plugged in to the EDAC. So this will give us a much cooler looking plot. As a matter of fact, not just cooler, but one that's right. And I'm going to color this again with speed from the GPS. Say OK here. Where are we in the world? Let's zoom in and find out. All right, so here we go. Now we have the route that Scott drove just the other day. So what we've done here is this is actually, rather than using a plain, boring, gray background, or using Microsoft MapPoint, which we've been doing for the last couple of years, instead, now this is using an open map, an open source map, and it's called, if I can remember the name, it's MapQuest Open. Okay? This comes from a project called Open Streets, Open Street Maps. All right? Rory, question?
Does this imply that it's basically you need an internet connection or whatever to access this data?
So the question is, does this need an internet connection to access this data? And the answer is yes. Okay? So this is actually going out to a website and saying, for this latitude and longitude, what's the picture underneath it? So, but the nice thing about this then is we've had requests since day one with GPS. Someone says, okay, you can look at this on a plain gray grid background, or we can look at Microsoft MapPoint, but A, we don't have MapPoint. We just don't like it. You have to buy it from Microsoft. We don't like Microsoft. We don't like buying things from Microsoft or whatever. We just don't have it. So a question has often come up, how do I get Google-style maps or something that looks like my phone? How do we get that up here? And that's what this is. Now, I can't pinch and zoom. It's not that, but it's something you'd recognize. You know, I can take a look here, so I can come and see where actually did Scott drive that day. So we'll take a look down here. Take a good close look. Where did you drive that day, Scott? Where's this?
That looks like Costco.
Went to Costco. Yeah, yeah. So, you know, one of the beauties of working for HBM is that you can have an EDAC running when you go to Costco. You can collect data at all times, So you could say that this would be the expensive version of watching your child drive, right? There are cheap versions of the dash cam, that kind of stuff. Now this would be the slightly more fully featured, including calculated channels, burst modes, and all that cool stuff. 100K sample rate, aggregate, and all that. Anyways, you can see here that it looks like Scott successfully negotiated without stopping 2 entire roundabouts. So congratulations, Scott. I believe the first American to have done this, negotiated 2 roundabouts in a row with, and as you can see by speed here, he even did not stop. So no need to sideswipe anybody, or kept going after he did. Who knows what that means exactly. Anyway, so this is something you can't do right now. This is beta software, okay? So look for this late summer. One last thing I want to point out about GPS, and that is that a lesser known feature that it seems that's quite useful, but a lot of people seem not to jump into, is I can highlight a region like this. So I have this highlighted region now. So I've said, anytime I get inside this region, I want to grab this information. this will create what we call a feature list. So if I use a display glyph here, this has been around, by the way, this came in at version 8 of GlyphWorks. I'm showing this in something newer, but this is something you can do right now. If I have this, now I can take my raw time series data and answer the question, when was I inside this colored polygon? So what's happened now is it's highlighted this last region here. These are the time segments that correspond to when I was inside this volume, this polygon right here. This can be very useful for trying to separate with over-the-road testing, trying to separate out certain parts of a road, an exit ramp, for example. Trying to separate out parts of a proving ground, residence road going this way, twist ditch, come back, that kind of thing. Long data file. Show me only when some condition is true. Only when I sit inside some volume. This, again, I'm showing this as if it's new. This is actually came in at GlyphWorks version 8. It's been around for a little bit. Okay, let's move on and look at a couple of other things. Other ways I'm analyzing the data that Scott collected. Down here, this is what we call a time at level analysis. How much time was spent at various magnitudes. So how much time was spent at different speeds, if you may wonder. Not just what's the maximum speed, but what's the distribution around that maximum. So here we can see that Scott apparently spends quite a bit of time stopped. This is a highway run, so quite a bit of time between that 60 to 80 kind of miles per hour range. We can only hope this is not the roundabouts right here. Yep. Yep. Yeah, we don't have any indication of driver behavior directly by looking at this plot, but you can certainly make up stories along the way in doing so. All right, so nothing new here. This is what we call time at level. I want to take a look here at this new glyph here called Xyz Display. This one came in at version 9. So this is for looking at, you could say, multivariate plotting. XY display glyph has been around since day one for plotting things like G's versus frequency, pressure versus time, X versus Y, XY display. So a logical extension to that, XYZ display, look at things in 3 dimensions. And you'll actually see, if we had more letters in the alphabet after Z, we could actually call this an XYZ, Z2, Z3 if you wanted, because we can actually get 5 dimensions. It really hurts for me to visualize things in 5D. It doesn't, I can't get my head around it. If you can come up here and talk. Please do so. But this will plot in 3-dimensional space, actually up to 5 variables. Okay? So what I'm showing here is this plot that shows gear position. This is straight off the CAN bus. So 6-speed transmission. So 1, 2, 3, 4, 5, 6. Versus speed, vehicle speed, and versus engine speed. So if I look inside the guts of this XYZ display glyph, under data lines, we have, kind of like the GPS display glyph, I have a list of what's the x-axis going to be, what's the y-axis going to be, what's the z-axis going to be, and this will plot up, in my case, I'm plotting at points or spheres. I could connect them with lines if I wanted to. Color and size. So this would be the 4th dimension where my head starts to hurt, and the 5th dimension where everything starts to really explode. Okay, so in my case here, I'm putting, I have X as vehicle speed, Y as engine speed, Z as gear position, and I'm actually coloring by gear position. So as we move up this, points that are higher are colored. It just happens to make the layers easier to look at. These displays, you really got to rotate them around and look at them different ways to understand what's going on. For example, this is the top-down view, like this. Side, so we're just taking 1 speed out. You can see that, no surprise, I'm in the highest gear at the highest vehicle speeds. But if I look at it this way, you can see now I'm not in the highest gear at the highest engine speed. So these would be kickdowns, right? So these are downshifting from 6 to 4, 6 to 5 for a passing condition. And So this type of a plot this way, looking at this as this distributed plot, can help us understand trends, especially with CAN bus data, where we have all these parameters now, and we can look at a transmission in a different way than we did before, very quickly visualize. I've seen some other people use this as well, looking at XYZ load on a mount, where we have 3 orthogonal loads on a mount. How do those 3 loads combine? What's the orientation of those 3 loads in space? Every time step there's X, Y, and Z. We could plot out X versus Y versus Z load here to look at orientations of loading as well. Okay, so this is XYZ display glyph, new to ENCODE 9. So all of you have access to this right now. Okay, the last thing I want to show here today, this is certainly not a tutorial on how to use every glyph in GlyphWorks. I'm just trying to keep this high level and focus on a couple things to point out trends we can find in Scott's data. I want to look at how video plays into this. The beauty of working with an SIE file is that, as you saw earlier when Scott was describing the transducer channels he was recording, along with time series data, we also have video. So we have this video here. That's the wrong one. Excuse me just a second here. Yeah, that's Scott's head. It's a thing of beauty. Yeah, so let me just jump in here. And actually, we want to grab this one instead. All right, so let's just let this play for a minute. I'll talk while it's going. Okay, so one of the nice things about the EDAC is that we have video sharing a clock, time synced with all this other channel data. GPS, CAN, accelerometers, all that kind of stuff. So that means then the time sync here of time series and GPS and video all fit together. GlyphWorks can deal with video from other sources. It's just you'll have to make sure the time sync is set. So we have a property inside this glyph right here that says what's the start time of this relative to that. Now that becomes completely immaterial when you're working with SIE video because the time sync is already in there. If you had an external video, if you had a video camera in a test lab recording and used a different data acquisition system, then we can sync that up, but it's have to be done manually. Okay, but so let's see where Scott went that day. Let's see what was going out the front window. I'm going to skip ahead here just a little bit. And you can see there he is. Now he's driving along. So this is more or less, we could be looking at the data that was collected this morning. We'd find where Chris went in Scott's vehicle today. Now we see how Scott drives in Scott's vehicle, which may be different. Who knows? So now we have the ability to point out what happened, where were we, and also, whoa, stop there. Also, what was going on at the same time. I was kind of worried, you know. I guess that I should have channel data. No, yeah, okay. Gotcha. So this is video. All right, so questions or comments about video?